Good morning, dear students. My name is Ferhan Mazher, and the subject today we are studying is Cambridge IGCSE Physics, Extended Physics. The code of the subject is 0625. Today we have selected a paper 2 of this subject, and we have selected October-November 2023 2-3 paper. This paper 2 belongs from the Zone 3. This paper is a multiple choice, has multiple choice questions. There are 40 questions, and the time allowed for this paper is 45 minutes. So let's start this MCQ paper, and here we go. Okay, so the paper is showing up on your screen. This is October-November 2023. So let's start. The time allowed is 40 minutes, and the G value will be taken as 9.8 Newton, 9.8 meter per second square. And the first question is showing up. So he says, how many of the quantities shown are scalar? Okay, so we are looking for scalar quantities. Okay, so mass is a scalar quantity. So mass is a scalar quantity. Momentum is a vector quantity. Density is a scalar quantity. Energy is also a scalar quantity. So there are 3 scalar quantities. So I think C is the right option. So let's check. C is the right option. So here we go. C is the right option, sir. Okay. Now, question number 2. A train is on a straight track. The graph shows how a quantity y varies with time. Which statement can be true? The train is stationary and y represents the distance from the last station. Okay, so if the y is distance, then this distance time graph, if the line is horizontal, that means the thing is stationary. So yeah, this can be true. This can be true. Okay, so then he says the train is moving and y represents the distance from the last station. So if the train is moving, then the graph cannot be horizontal if the y is distance, okay? The train is stationary and y represents the speed of the train. If the y is speed, then the stationary, which means the speed is 0, then this horizontal graph should be on the x-axis. The train is moving and y represents the speed of the train. Yes, that can be possible. If the y is speed and the speed is if the train is moving with a constant speed, then that can be possible. The train is moving and y represents the speed of the train. That can be possible. A train is on a straight track. The graph shows the y varies with the time. Okay. So 4, I think 4 can be true also. Let's check. I think that the question number 3, 1 and 4 is the option. So I think B can be the option. So B is the right option. Question number 3. The diagram shows a speed-time graph for a moving object. Which description of the object motion is correct? Okay, so this is a speed-time graph, and the gradient here basically represents the acceleration. So if you look at the gradient is gradually decreasing. So if the gradient is decreasing, that means that the acceleration of the object is gradually decreasing. So because the gradient of this graph is equals to the acceleration. So which description of the object motion is correct? Decreasing acceleration? Yes, that is true. Decreasing speed? No, the speed is gradually increasing. Decreasing speed? No. Constant acceleration? No, no, no. Constant speed? No. You see, this is a speed time graph. In the speed time graph, the gradient of the speed time graph represents the acceleration. Because the gradient you can see is gradually decreasing, that means the value of the acceleration is actually decreasing. So this is question number 3. A is the option, sir. Question number 3A is the option, which is the right option, sir. Okay. Now we are going to the next question. That is question number 4. He says the mass of air hitting the blades of a wind turbine each second is 1.5 x per 4 kg. In 1 second, this much air is hitting the blades. The speed of the air is 4 meter per second. The density of the air is 1.2 kg per meter cube. Which row gives the volume of the air hitting the blades each second and the kinetic energy of the air hitting the blades each second? Okay, so we know the density, we know the mass of the air, we can find the volume. We know, if we know the mass and if we know the speed of the train of the air, we can find the kinetic energy. And here we have on your screen, I think it's visible. First of all, the mass is given, that is 1.5 x per 4 kg. The density is 1.2 kg per meter cube. The volume will be mass divided by density. So 1.5 x per 4 divided by 1.2, and the answer is 12,500 meter cube, which is approximately 13,000 meter cube. Okay, so the volume is 13,000 meter cube. Now the kinetic energy, you know, is 1 by 2 mv square. So 1 by 2 into 1.5 x per 4 into 4 square, and that will be 120,000 joule. So the volume is 13,000 meter cube, and the kinetic energy is 120,000. So I think volume is this. Okay, so the B is the option, sir. So question number 4, B is the option. Question number 4, B is the right option, sir. You can see in the marking scheme. So this is how this is solved. I hope you understand. Okay, so we are going to the next part. Next part is question number 5. He says, an object moves in a circle at constant speed. You see, whenever you move in a circle, so every moment your direction has to be changed. Although you are moving with the constant speed, there is a resultant force which is directed towards the center of that circle. And there is acceleration in the body. That resultant force is called a centripetal force. Which statement about the force needed on the object is correct? A force away from the center of the circle keeps the object moving in a circle. You see, the force which keeps the body in a circle is always directed towards the center of the circle. A force in the direction of the motion of the object keeps it moving in a circle? No. A force towards the center of the circle keeps the object moving in the circle. Yes, this is the right description of the centripetal force. No force is needed to keep the object moving at constant speed in a circle. That is wrong. We need a resultant force when you move in a circle, although your speed is constant. So I think question number 5C is the right answer, sir. Question number 5C is the right answer. Okay, so here we go. Question number 6. A uniform rod rests on a pivot at its center. The rod is not attached to the pivot. Forces are then applied to the rod in 4 different ways, as shown. The weight of the rod can be ignored. Which diagram shows the rod in equilibrium? You see, if you look at here, this is 100 Newton force producing clockwise moment. This is 100 Newton force producing anti-clockwise moment. This is the center. These two forces are acting on the extreme ends. So this will be 100% in equilibrium. This force, the force will be acting, both the forces are acting in the upward direction, and the pivot is under. So the forces will not be balanced. So this is not in equilibrium. This is producing clockwise. This is also producing clockwise. So this is not in equilibrium. Clockwise, anti-clockwise, but this is not balanced. This is clockwise. This clockwise and this anti-clockwise. This is trying to produce a clockwise moment. This is trying to produce an anti-clockwise moment. Both the forces are same. Their distance from the pivot is same. So they will be cancelled with each other. But this force is producing a clockwise moment, which is not balanced. So this is not in equilibrium. So I think question number 6A is the answer. Question number 6A is the right answer, sir. Okay. Now we are on the question number 7. He says a car of mass 1200 kg is traveling along a straight horizontal road. Which impulse is needed to accelerate the car from 5 meter per second to 10 meter per second? You see, the impulse is change in momentum. The impulse, there are two formulae for the impulse. One is change in momentum, and the other one is force multiplied time. Here we know the final velocity, we know the initial velocity, we know the mass of the body. Very easily I can calculate the change in the momentum. So impulse is equals to change in the momentum. So we will calculate this. Let me show you. You see question number 7 on your screen, impulse is equals to change in the momentum. So impulse is equal to mv minus mu, final momentum minus initial momentum. So 1200 multiplied 10 minus 1200 multiplied 5, and the answer will be 6000. The unit can be Newton second, or it can be kg meter per second. You can write whatever unit you want. 6000. So question number 7, A is the option, sir. Question number 7 is the right option. This is how this is done. Okay. Question number 8 is showing up on your screen. A mass bounces up and down on a steel spring. The diagram shows the mass and the spring at different points during the motion. So that spring is moving up and down. So this is the highest point, mass moving downward, lowest point, mass moving upward. Okay. Then the question is, at which point is the least energy, the word is least, minimum, energy in the gravitational potential stored? Okay. And the least gravitational potential energy will be there where the body is at its lowest point. So if you look at here, yeah, when the body is at its lowest point, and at which point is the most energy in the elastic store of the spring, the elastic potential energy. Where is the elastic energy maximum? See, very simple. Here is the spring is stretched. So it has elastic potential energy. So at lowest point, the gravitational potential energy store is lowest, and elastic potential energy store is maximum. So both the things are when the body is at its lowest point. So we think D is the answer. So question number 8, I think D is the answer. Okay, question number 8, D is the right answer. Let me show you the full question, reduce the size so you can see the whole thing. Okay, so this is how this is done, a very simple question. Okay, now we are going to the next question. The next question is question number 9. He says a boy uses a rope to pull an object of mass m up a slope. The rope is parallel to the slope. The tension in the rope is constant and of the value F. The object moves distance d along the slope, and rises through a height h. How much work is done by the boy? You see here, the work done can be calculated by two ways. One is the force multiply the distance moved in the direction of the force. That's one method. In that case, it will be F multiply the distance moved in the direction of the force, in the length of the ramp, and that is d. So it will be F multiplied d. The other method is the work done is equals to the gain in the potential energy, and that will be mg multiply the vertical height gained. That will be mgh. So the work done can be calculated by two ways. One, force multiply the distance moved in the direction of the force. And the second method is the gain in the gravitational potential energy, mgh. mgh is not given in the options. So the only option which is correct now is F into D. So question number 9A is the answer. Our answer is A. Hopefully you understand. Question number 10. He says a microwave oven is rated at 900 watts. Which statement correctly describes the meaning of this value? 900 watt rate of the transfer of the energy, that means 900 joules of energy is transferred in every second. That's the definition. Very simple. 900 joules are transferred every second. This is the exact definition of the power. So I think question number 9A is the right option. Question number 10, sorry, is the A option. Yes, sir, it's the A option. Question number 11. An object is immersed in a liquid of density rho. The pressure at which this depth due to the liquid is rho. Is P, sorry. The gravitational field strength is G. What is the equation for the depth H of the object beneath the surface? You know, the pressure of the liquid at a depth H is pressure is equal to rho GH. So if you make H the subject of the formula will become pressure divided by rho G. Pressure divided by rho G. Do we have that option there? Pressure divided by rho G. Yes. So I think C is the right option, sir. Question number 11, C is the right option. This is how we have found it. So, question number 12. A sealed bottle of constant volume contains air. The air in the bottle is heated by sun. What is the effect on the average speed of the air particles in the bottle and the average distance between them? So look at this very important words. The sealed bottle of constant volume. So the volume of that air is constant, so the distance between the air molecules cannot be changed. So it is heated. So when you heat, the volume is constant, you are heating it. So the kinetic energy, the particle speed, that will definitely increase. But the distance between the air particles, that will remain same. Increase and stays the same. So I think D is the right option, sir. Question number 12, D is the right option. Question number 12, D is the option, sir. So on your screen, the question number 13 is showing up. In an experiment to investigate the relationship between the volume of a sample of air and its pressure, the volume of the sample is decreased and its pressure is measured continuously. The curve X on the graph shows the results that would be expected for a fixed mass of air at constant temperature. The curve Y shows the results that are obtained in this particular experiment. So this curve Y is basically the ideal thing, that when you will decrease the volume, the pressure will increase. If you halve the volume, the pressure becomes double. When the temperature of the gas is constant, the volume and the pressure, they are inversely proportional to each other. But when they do it in experiment, they got these results, the Y curve. Now you see, when they decrease the volume, the pressure has not increased that much. So why the pressure has not increased that much? Which row shows two possible reasons why the curve Y is different from a curve X. You see, there are two reasons discussed here. One is temperature, and the other one is the volume, the air, the amount of air in that cylinder. Because when you have decreased the volume, normally what happens when you compress something is temperature rises. So, but if the temperature will rise, then the pressure should increase. But here the pressure has not, in the y curve, when you decrease the volume, the pressure has not increased that much. That means the temperature has not increased, or might be that the temperature has actually been actually decreased. Because if the temperature increases, the pressure would increase. Here the pressure has not increased that much, which was expected that the pressure will increase. So if the temperature would have raised, the pressure would have raised also, yeah, would have increased, I mean. So the temperature, I think, has decreased. And this is, the pressure has not increased that much. The other reason can be that some of the air might have leaked out of the container. That can be another reason that why you are decreasing the volume of the gas, but the pressure of the gas is not increasing that much as it was expected. So it's a very, very tricky concept. So D is the right option, sir. Why D? The temperature of the air decreases as the volume is decreased. Air leaks out of the container as the volume is decreased. The reason is you have decreased the volume of the gas and the pressure of the gas has not increased that much, which was supposed to be increased. So how this is possible? Why the pressure has not increased? You cannot say the temperature has increased, because if the temperature will increase, then the pressure will automatically increase more than your ideal situation. And the other reason can be that some of the gas has leaked out of the container. So D is the option. Very tricky, very conceptual. You have to think a lot before you can answer that. So we think question number 13, D is the answer, sir. D is the right answer. Very, very tricky question. Its answer is not easy. Now we are on the question number 14. He says a student splashes water on her face. Here are three statements about the effect. Okay. So the water uses energy to evaporate. Yeah, that's right. The water gains energy from the student. That is also right. The face of the student cools. That's why you splash. When you splash water on your face, you feel coolness. Yeah. Which statements are correct? So I think P, Q, and R, all the statements are, seems to me that they are correct. This happens. Question number 14, D is the answer, sir. D is the right answer. Four containers, each contain water. More water at the same temperature is added to each container. From which container does the water now evaporates more slowly than it did before? You see, the rate of evaporation depends upon the surface area. So in this container, if you add more water, the surface area will remain same. So rate of evaporation will not change. In this, when you will add more water, the surface area will increase. Now the rate of evaporation will increase. In the D option, because it was a straight, so when you will add more water in it, the surface area will not change, the top surface of the liquid. So the rate of evaporation will not change. But in the C shape, when you will add more water, when the level of the water will come here, the top surface area of the water will decrease. So the rate of evaporation will decrease. It will become slower than before it was. So I think C is the option. Question number 15, C is the right option, sir. Question number 16. A cupboard is placed in front of a heater. The air can move through a gap under the cupboard. Which row describes the temperature and the direction of the movement of the air in the gap? You see, the hot air, which will be less dense, that will rise from here. Okay. And the cold air, which will be more dense, will be coming from this gap here. So the air in this gap is cold and its density is more. So which row describes the temperature, the direction of the movement of the air in the gap? The air in the gap will be cool and it will be moving towards the heater and it will be more dense. That's the concept of the convection currents. So the air in that gap is cooler and its direction is towards the heater. So we think B is the right option. We think B is the right option. Question number 16. B is the right option, sir. B is the right option. Okay. Question number 17. Light diffracts when it enters a telescope. This causes the image to blur slightly. The amount of diffraction depends upon the diameter of the hole through which the light enters the telescope and the wavelength of the light. Which combination of diameter and the wavelength will result in the sharpest image, least blurring? So light diffracts when it enters the telescope. This causes, so this diffraction is causing the image to blur. So if you want to reduce this diffraction, you see what you need to do. The wavelength should be shorter and the diameter should be larger. Means the diameter of the telescope must be larger than the wavelength of those lights. So then the diffraction will be less. So here, because the image is getting blurred due to the diffraction, and if the gap through which the light is passing, if that gap is less than the wavelength, then the diffraction will be more and more. If that gap or that diameter of the hole is larger than the wavelength, then that diffraction will be less, and then will be less blurriness in the image. So diameter should be larger and the wavelength of the light must be smaller. So question number 17, B looks the right option to me, sir. That is right answer. Question number 18, the diagram shows a transverse wave. Which row identifies the amplitude and the wavelength of the wave? You know, the amplitude is from the mean position, how high maximum you go, or from the mean position, how low you go, from the mean position. So I think P is the amplitude and the distance between the two consecutive crusts is called the wavelength. So that is S. So P and S. So I think B is the right option. Question number 18, B is the right option. Then we have question number 19. The diagram shows the effect of a prism on white light. Some light is reflected on striking the prism and some is refracted and dispersed to form a spectrum. White light has 7 colors. So a spectrum, a band of 7 colors will be visible. What happens if the monochromatic light is used? Monochromatic light is used instead of the white light. Monochromatic light means a light which consists of only one color. It's blue color, or it's red color, or it's orange color. So only one color. So when that single colored light will pass through the prism, obviously there will be no band of colors formed when it will emerge from the prism. The light changes color as passes through the prism. No, the light forms a brighter spectrum. I don't know. There is no reflected light. No, that's not true. there is no dispersion of the emerging light yet. That's right. The dispersion of the light will not take place, I think. D is the right option. That spectrum will not be found because now the light is consisting of only one color. So question number 19, D is the right option, sir. Question number 20. The diagram shows a ray of light incident on a plane mirror. Okay. The angle between the ray and the mirror is 35. The ray is reflected by the mirror. What is the angle of reflection? So we want to find out the angle of reflection. So first of all, I will draw a normal here. So normal is a line which makes 90-degree angle with the surface of the mirror. Okay. Angle of incidence is the angle with the incident ray makes with the normal. So the total angle with the surface is 90. So 90 minus 35. So the angle of incidence will be 90 minus 35. So that will be 55. You know the angle of reflection and angle of incidence, they both are equal to each other. So if the angle of incidence is 55, the angle of reflection will be also 55. So I think B is the option. Question number 20, B is the right option, sir. Question number 21. A thin converging lens in a camera produces a real image on a photosensitive surface, as shown. At which position is the image of the top of the object formed? You see, because this is a real image, and the image will be inverted. Inverted means upside down. So the top will become the bottom of the image, and the bottom of the object will become the top of the image. So the top of the object will be the bottom of the image, that is C. So I think C is the right option. It's a conceptual question. 21C is the right option, sir. Then we have question number 22. Light is traveling through air. It strikes a glass block at an angle of incidence of 45 degree. The glass has a refractive index of 1.4. What is the angle of refraction of the light as it enters the glass? You know, the refractive index, we represent it with the N. That is equal to the sine I by sine R. It can be also sine R by sine I, but upstairs we put that angle which is in the rare medium because the light entered from air into the glass. So the angle of incidence is in the rare medium. So N will be equal to the sine I by sine R. So we will have question number 22. So sine I by sine R. So 1.4 is equal to sine 45 divided by sine R. So sine R will be equal to sine 45 divided by 1.4 equals to, and that will be 0.505. So R will be equal to the sine inverse of 0.505, and that will be 30.3, which is approximately 30 degree. So the angle of refraction will be 30 degree. Okay. So I think B is the option. Question number 22, B is the right option, sir. Question number 23. Which row gives approximate values for the speed of the sound in copper, water, and air? Copper is solid, so the speed must be highest. Water is liquid, so here the speed should be medium. And air is gas, the speed must be lowest. In air, we know that speed is approximately 300, 320, maybe 350. So the highest speed must be in the solid. So that correct order is only given here. 4,500 meter per second, in the liquid 1,500, and in the air 350 meter per second. So I think A is the option, sir. Question number 23, A is the right option. Question number 24, he says, which metal can be attracted by a magnet? The famous metal which is attracted by the magnet is iron, without doubt. Question number 24C is the right option, sir. Here we have question number 25. The diagram shows an electric circuit. In which direction do free electrons flow around this circuit, and which quantity does the ammeter measure? You see, ammeter measures the amount of current, which means the amount of charge per second passing from a point. Now he's talking about free electron flow. Free electron flow goes from the negative terminal of the battery and go in this way. So the free electron flow will be clockwise. Sorry, this is not clockwise. This is anti-clockwise. Sorry, anti-clockwise. And the ammeter measures the amount of current, which is the charges flowing per unit time. So what are the options? The direction of the electron flow will be anti-clockwise, yes. And the charges passing each point in the circuit per unit time. Yes, that's the definition of the current. So I think without doubt, A is the right option, sir. This is question number 25. We think A is the option. Yes, that is right. So question number 25, A is the right option. Question number 26. Which substances both contain large concentrations of free electrons? Aluminium has free electrons, glass do not have, copper have free, water do not have, copper have free electrons, nylon, it do not have free electrons. The D option is silver. It's a metal. It has free electrons. And gold. Gold also has free electrons. So they will have more free electrons because silver and gold. D is the right answer, sir. So we are on question number 27. A resistance wire of length L melts and has to be replaced with a wire of the same material and the same resistance. The only wire available has twice the diameter of the broken wire. Which length of this wire should be used? You know, because the diameter of that wire has become double, and the two things which are similar to each other, and if the diameter becomes double, so what happens with the cross-sectional area? In your mathematics, you have studied about the similar solids. So area 1 by area 2 will be equals to the diameter 1 by diameter 2 whole square. So the wire 2 has a double diameter. So D and D will be cancelled. So it will become 1 and it will become 4. 2 square is 4. So the area 2, the cross-sectional area of the second wire, is 4 times the cross-sectional area of the first wire because it has twice the diameter of the broken wire. Okay, this is a very, very important concept. Okay, so then because both the wires are made of the same material, so their resistivity is same. So resistivity of the first wire and the resistivity of the second wire, they are same because they both are made of the same material. So you know the resistivity is resistance multiplied cross-sectional area divided by the length. So R1 A1 by L1 equals to R2 A2 by L2. So R1 is R, area 1 is A, length 1 is L. R2 is this, it has the same resistance, okay? The area 2 is 4 times the area 1, 4A, and L2 is question. So A and A cancelled, R and R cancelled. So the L2 will be equals to 4 times the length of the first wire. So the answer is 4L. It's a very tricky question. Question number 27, D is the answer. which is right answer, sir. So question number 21, D is the answer. Okay, now on your screen, question number 28 is showing up. A teacher wishes to show the production of electrostatic charges. She holds a rod and rubs it with a cotton cloth. A copper rod, a glass rod, a plastic rod, and a steel rod are available. Which two rods would both be suitable to use? You see, when you produce charges by the help of friction, both the materials should be insulators. So, insulators is glass rod and plastic rod. This is cotton cloth. This is obviously insulator. So, plastic rod, glass rod, and a plastic rod. Yes, this is the option. B. 28B is the right answer, sir. Question number 29. Two resistors with the resistance R1 and R2 are used as a potential divider. What is the relationship between R1, R2, and the potential differences V1 and V2? The more the resistance, the more will be the potential drop across it. Less the resistance, the less will be the potential drop across it. That's a simple relationship. So R1 by R2 should be equals to V1 by V2. So I think D is the answer. Question number 29. D is the right answer, sir. This was question number 29. Yeah. Question number 29. D is the option. So you see, the voltage drop across a resistor depends upon the resistance. More the resistance, more will be the voltage drop. Less the resistance, less will be the voltage drop. So on this, I come to this. This is potential divider. Okay, so you can. Now we are going to the next question. That is question number 30. He says the diagram shows a light dependent resistor LDR connected in a potential divider circuit. So here you have the LDR, here you have fixed resistor. Here we have a voltmeter which is across the LDR. So in the LDR, you know what happens when the light falls on it, its resistance decreases. And when there is less light, its resistance increases. When the resistance will increase, means it's dark, the voltage drop will be more. And when the light will be more, the resistance of the LDR will be less. So the voltage drop or the reading on the voltmeter also less. The brightness of the light falling on the LDR is increased. So you have increased the light. So the resistance of the LDR will decrease. When the resistance on the LDR will decrease, the reading on the voltmeter will also decrease. Which row shows what happens to the resistance of the LDR and what happens to the reading on the voltmeter? They should decrease. A is the option. Yes, that's true. I hope you understand. These are pure conceptual questions. And basically, you see, when we are making these videos, the aim is to make the videos basically for the students who are preparing for the final exam of the Cambridge. So we hope that they have the basic concepts. Question number 31. A simple AC generator has a coil rotating in a magnetic field. What happens to the peak electromotive force and to the frequency of the AC output when the coil is rotated faster? You know, if the coil of the generator will move faster, its frequency will increase. In unit time, it will complete more and more revolutions. So the current which is induced, it will have more frequency. And when you rotate the coil in the generator faster, the voltage which is induced, the EMF which is induced is also greater. So the peak EMF will be greater, the frequency will be greater. when the coil is rotated faster. So I think A is the option, sir. Question number 31, A is the option. Yeah, that's right. Okay, now we are on the question number 32. A current passes through along a wire placed between the poles of a permanent magnet. The wire experiences a force due to the magnetic field. What will change the direction of this force? Okay, so it's a current carrying wire placed between the two magnets, and obviously this experiences a force. And what will change the direction of this force? Two things can be done. Do one at a time. Okay. For example, you can change the direction of the current. Obviously, the direction of the force acting on that wire, that current carrying conductor will change. It will reverse. Or don't change the direction of the current. Do other thing. What is that? Change the polarity means of the magnets means that on the left you have north, on the right you have south. So bring the north on the right and take the south to the left. Increase the current? No. What will change the direction of this force? Increase the current? No. Reversing the current? Yes. Reverse the current. The direction of that force will change. This is right statement. Increasing the strength of the magnetic field? No. Using an electromagnet with the same polarity as the permanent magnet? No. B is the right option, sir. Question number 32, B is the right option. Question number 33. He says, what is a transformer used for? You see, transformer is used to either increase the voltage or decrease the voltage, or to increase the current or decrease the current. Changing a direct current into an alternating current? No. Changing the magnitude of an alternating voltage? Yeah. Reducing the frequency of alternating current? No. Switching off the current in a circuit when there is a fault? No. Reducing, this is changing the magnitude of an alternating voltage. Yes, this is the main purpose of the transformer. So, what was the question number? 33B is the option. Yeah, that's right. Question number, we have 34. The scattering of alpha particles by a thin gold foil provide evidence for the nuclear model of the atom. Two alpha particles of the same energy are incident on a nucleus of gold. Which diagram shows the correct paths followed by the alpha particles as they pass close to the nucleus? So you see, when the alpha particles pass through, the particles are very close to the nucleus. The nucleus is positively charged, and those alpha particles are also positively charged. So the alpha particles, which one is nearer to the nucleus, its path is nearer to the nucleus, that will be deflected more, and the other alpha particle which was little at a distance as compared to the other alpha particle from the nucleus, that will be deflected less. Alpha particles are positive, the nucleus is positively charged, so they will be repelled, basically not attracted, they will be repelled. And the alpha particle which is near, it will be repelled strongly, and so it will be deflected more. And the one which is at a distance from the nucleus, it will be also repelled, it will be deflected, and it will deflect less because it experiences a less repulsive force because its distance from the nucleus is more. So I think A is the option. A is the option, sir. Here the diagrams are correct. 34, A is the right option, sir. Question number 35. So, the half-life of carbon 14 is 5,700 years. An object containing carbon-14 has a count rate of 100 counts per minute when it is first formed. The graph shows how the count rate decreases over time. Which point on the graph corresponds to a time of 11,400 years after the formation of the object? Okay. Now, 11,400 years, its half-life is 5,700 years. So that means two half-lives have passed. The count rate at the start was 100. So after one half-life, it will become half. Now it will be 50 counts per minute. Another half-life will pass and the count rate will become further it will have. So it will become 25. So after 11,400 years, the count rate will become 25. So you see, this is 50. And you know, this is 25. So this is basically 25. So 25 corresponds to which point? I think it's D. So after 11,400 years, two half-lives would have passed. From 100, it will go to 50 in one half-life. From 50, in another half-life will pass, it will go to 25. So I think D is the right option, sir. Question number 35, D is the right option. Question number 36, he says, why are beta particles deflected more strongly than alpha particles when they enter an electric field? You see, the beta particles are negatively charged and their size is very small. That's why they deflect more. Alpha particles, they are larger in size. So when they deflect, they take not a sharp turn. But the beta particles, when they are deflected, they take a very sharp turn. So beta particles have less mass than alpha particles. This is the main reason. Beta particles are negatively charged. No, beta particles, yes, they are negatively charged, but this is not due to negative charge. Beta particles have lower velocities than alpha particles. Beta particles have more ionizing power than alpha particles. No. So I think 36A is the right option, sir. It's a famous sentence in your book. Okay, question number 37. Which statement describes how nuclear energy is released by fission in a nuclear power station? In fission, you see what happens? You bombard a nucleus with a neutron, and the nucleus breaks. It splits into smaller nuclei. Atoms join together to make molecules. No, heavy nuclei split into lighter nuclei. Yes, this is fission. Light nuclei join together to form heavier nuclei. That is fusion. Molecules break into atoms. No, that is some chemical reaction. Okay, so heavy nuclei split into lighter nuclei. This is called fission. Okay, so B is the option. Question number 37, B is the right option, sir. So here we have question number 38. Okay, so it's a tricky question. The diagram shows a star S and the initial arrangement of three planets X, Y, and Z. Each planet orbits clockwise. So each planet is moving clockwise. Okay. So they are moving like this. Means when I look here, it's clockwise. Okay. So each planet orbits clockwise in a circle about S. The time for one orbit of Y is 3 times taken by one orbit of X. Okay. The time for one orbit of Z is twice the time taken for one orbit of Y. Okay. So if the X will take T time, the Y will take 3T, and the Z will take 6T. Okay. Starting from the initial arrangement, which diagram shows the position of the planets after X has made one complete orbit. Okay, so try to understand this thing. Okay, so for x in t, it completes 360 degrees, so it's complete one cycle. Okay, for y, to complete 360 degrees, it takes 3t. So in t time, how much angle it will move? It will move 120 degree. It will move how much? 120 degree. And the planet Z, in 60 time, it covers 360 degrees. So in t time, how much it will cover? It will cover 60 degrees only. Okay. Now they are moving clockwise. So y will move 120 degrees and the z will move 60 degrees, and they are moving in which direction? Clockwise. So initially they are here, so they are going clockwise. So y will move 120 degree. So here it will be 90. Here this line shows 90 degree. So I think the y will be here somewhere. The y will be here somewhere. And the z will cover 60 degrees, so the z will be here somewhere. So which diagram is suitable? This one. They are going clockwise, okay? So I think B is the right option. The z has moved 60 degrees, but the y has moved 120 degrees. I think B is the answer, sir. 38B is the answer. It's a little not that difficult, but it's difficult. It's not easy. Yeah. It involves mathematics and your physics. Okay, so we are on the question number 38. He says the nearest star to the sun is about 4 light years away from Earth. Okay. From Earth, it is 4 light years away. A student makes 3 statements about the star. Light from the star takes about 4 years to reach the Earth. This is right. That is the meaning of this sentence. Light from the sun takes about 4 years to travel to the star and back to the Earth. No, from the sun, it's also 4 light years away. So from the sun, if the light will go there, it will take 4 years to go there. And from there, if it comes back to Earth, it will take further 4 years. So it will be 8 light years. So it will be, I mean, the time will be 8 years. So this is not true. The star is outside of galaxies. No, the size of our galaxy is larger than the 4 light years. Which statement are correct? I think only the one. You know the size of our galaxy? So the size of the Milky Way, the diameter of the Milky Way is 100,000 light years. Light years. So 4 light years is very small distance. The diameter of the Milky Way is 100,000 light years. So this is only 4 light years. Okay, so this is very small. So okay, so C is the right option, sir. We have checked this answer. Question number 40. Let me check first. 39C is the right option. A planet orbits the sun with the orbital period T. The average radius of the orbit is r. What is the average orbital speed of the planet? You know the orbital speed of the planet is its circumference, 2 pi r divided by t. 2 pi r divided by t. So this is the answer, B. Question number 40, B is the right option, sir. I hope you have understood this question. Okay, so my dear students, today in this video, we have completed October-November 2023, 2-3 paper. This paper 2 belongs from the zone 3. This is Cambridge O-levels, Cambridge IGCSE physics, the extended physics. And I have tried my best to explain you the concepts of this paper. And I have tried to write the procedures and also describe the procedure so that you can understand. The problem is, one problem is that the main aim of these videos are for the O3 students who are preparing for their final exam. So that's why we do not go into too much details. If you find this video useful, if you find this video interesting, if you find this video helpful, please like this video, also subscribe to my channel, also share the link of this video on your WhatsApp groups, on your Facebook account, on your Instagram, on your Twitter accounts. You see, when you do this, you help me to promote my channel. And this support is very important for me. I think it's a great blessing for me that I can make these videos, which can be helpful to so many students around the globe. These videos can make the life of those students easier and the life of their parents and their teachers easier. It's a great blessing. Thank you very much for watching this video. Have a good day. God bless you all.